Hello, Math 80 students. I wanted to give you an example where you are factoring out a GCF where it is a quantity. So I have two examples for you. Here we go. All right, so to factor something where we have a GCF that is a quantity, in this case, x plus y to the third power is in both of my terms, this term and in this term. I can factor it out, so x plus y to the third, and what is left over is 8x squared plus 10y squared. Always make sure what you're left with, if it can be factored further, you should do that. So in this case, I can factor out a 2 from this expression from both terms. I'm going to put it out in front. And what's left over then is 4x squared plus 5y squared. So I just want to recap something. When you are factoring, you are undoing multiplication. So if I were to distribute this back in, multiply this back in, I'd have the x plus y to the third times the 8x squared, and I would have x plus y to the third times the 10y squared. So these two expressions are equivalent. If I took the 2 and I factored or multiplied it back into this, it would be equivalent to that. We just like to putting that in the front. So this is as factored as it can be. I do want to mention that you could also have noticed that there is a common factor of 2 initially and factored it out from the get-go, and then just say, well, dividing by 2, I'd have 4 here, dividing by 2, I'd have 5 there. So there is that shortcut. I want to do one more. Here we have another GCF that is a quantity. X minus 3 is a factor for each term. So I'm going to factor out the x minus 3. What I'm left with is x squared minus 4x minus 12. Again, if you distribute this quantity to each term, you get the above expression. But I'm left with this trinomial that can be factored further because there is something that multiplies to negative 12 and adds to negative 4, namely negative 6 and 2. Since my leading coefficient of what I'm factoring here is 1, I do not need to do the grouping. I can go straight to x minus 3 times x minus 6 times x plus 2, and now the expression is fully factored. To check my work, I would multiply these two together and then multiply that result by the x plus 2. All right, good luck.